Today we're going to be talking about atoms, and atoms are the basic building blocks of matter. Everything in the world is made up of atoms, and on Earth there are 92 naturally occurring types of atoms or elements, each differing from the other by the number of protons in the nucleus. All hydrogen atoms have 1 proton. All helium atoms have 2 protons. All lithium atoms have 3 protons, all the way up to uranium atoms, which have 92 protons. Now let's go ahead and talk about how to draw an atom. Let's start with the sodium atom. Now I'm going to write a sodium atom like this. I'm going to write sodium here, that's the atomic symbol for sodium. And I'm going to write an 11 right here. That 11 is called the atomic number. That atomic number is the number of protons. Okay? The number of protons in a sodium atom. Up here I'm going to write a 23. And that 23 represents the mass number, which equals the number of protons plus the number of neutrons. And I'm going to write an N superscript O because neutrons have a neutral charge. So by looking at this, I know that a sodium atom has 11 protons. I also know that the mass number is 23. The mass number consists of the number of protons plus the number of neutrons. By knowing this, I can figure out the number of neutrons by subtracting the two. 23 minus 11. That's going to give me 12 neutrons. So this atom has 12 neutrons. Now if I wanted to draw this atom, this is how I would do it. I like to start with the nucleus. And I'm going to write P plus equals 11. All right? Each proton has a +1 charge, a +1 electrical charge. And down below that, I'm going to write neutrons. And they are neutral. They have no electrical charge whatsoever. And there are 12 neutrons in a sodium atom. Now I got to figure out the number of electrons because I'm going to go ahead and draw the orbits. I've just drawn the nucleus here. Now I'm going to draw the number of orbits and put in the electrons. But how do I know how many electrons this atom has? Well, let's suppose that we're going to draw an electrically neutral sodium atom. It's electrically neutral. And I know electrons have a -1 charge. So how many -1 charges do I need to cancel out 11 positive charges? I need 11. So this atom is going to have 11 electrons in order to cancel out, electrically cancel out, the 11 positive protons. Now orbits are a little different. Each orbit can contain different numbers of electrons. For the purpose of biology, we're going to assume that the first orbit holds a maximum of 2 electrons, and each succeeding orbit can hold a maximum of 8 electrons. Now, in real life, there's some other rules that may apply there. But for biology, let's just stick with 2 electrons for the first orbit and 8 electrons thereafter. All right, so I'm going to go ahead and I'm going to draw an orbit here. And I like to draw the orbits with dotted lines. This is the path the electron would take. And electrons actually move around atoms billions of times per second. So you can't actually see these things happening. Now the first orbit holds a maximum of 2 electrons. So I'm going to put 1 electron up here. That's my 1 electron. And I'm going to put another electron down here. And notice they're on opposite sides because electrons have a negative charge. And they don't like each other. They repel each other. Okay? These negatively charged electrons are going to repel each other. So they're going to try to maximize their distance from each other. Now I'm going to move on to the next orbit. And it can hold a maximum of 8 electrons. Again, I want to space these electrons out. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now 2 plus 8, that gives me 10, but sodium has 11. So I got to go ahead and I got to draw one more orbit. And And there it is. And I'm going to put that electron right out there. This outermost orbit is referred to as the valence orbit. And the outermost electron, or electrons, are referred to as the valence electrons. And they're probably the most important electrons. And in fact, they're the electrons that are going to be responsible for chemical bonding, which we'll talk about in another video. Now let's go ahead and draw one more atom, phosphorus. So I'm going to go ahead and I'm going to erase this. And we're going to draw a phosphorus atom. Now phosphorus, which has an atomic symbol of P, has 15 protons in its nucleus. So it has an atomic number of 15. And I'm going to give it a mass number of 31. And mass numbers can actually change a little bit because the number of neutrons in an atom can sometimes vary. But the number of protons never changes. All phosphorus atoms everywhere in the universe have 15 protons. So let's go ahead and draw this. Okay? So I know that the number of protons equals 15. And I know that the number of protons plus neutrons equals 31. So 31 minus 15 gives me 16. So the number of neutrons equals 16 in this particular atom. The number of electrons, that's E with a superscript negative charge there. If I've got 15 protons, and this is an electrically neutral atom, then I need 15 electrons to cancel out, to electrically cancel out those 15 protons. So I also have, in this case, 15 electrons. Now I'm going to go ahead and I'm going to draw my atom. We're going to start by writing P plus equals 15. Number of neutrons equals 16. And now I'm going to go ahead and I'm going to draw my orbits. The first orbit, again, holds a maximum of 2 electrons. 1, 2. Now I've got 13 more electrons to deal with. So I've got to go out to my next orbit. 1, 2, 3, 4, 5, 6, 7, 8. Now I've used 10 of the 15 electrons. I've got 5 more to go. So I'm going to have to go out to the next orbit. And I've got 5 electrons. I'm going to go ahead and draw the 5 electrons in here. 1, 2, 3, 4, 5 electrons. And that is how you draw a phosphorus atom.